Okay, so we're going to do an investigation from page 394 of your textbook, and it's really cool. So I've drawn a triangle, and you can draw any random triangle. It doesn't matter. Pick a triangle. Okay? So I've got to label it. Let's label it here. So there's vertex A, vertex B, vertex C, right? Pick any letters you want. And then I want to measure the midpoint of this line. So midpoint means middle, okay? So midpoint means middle. So I have to measure this line, and then I have to split it up so that way this side is the same length as that side, okay? So if I take my handy dandy ruler, let's see, 17.3, so the middle of that is 8.6. So there's one midpoint, okay? So that means it's exactly in the middle, and I'm going to label that D. And then I'm going to do this side. So let's see, I measure that. That's 18 centimeters. Half of 18 is 9. So that means this side and this side are split up. There's my letter E. So they are exactly the same distance. So I've got my midpoints. Now I'm going to connect them to make a new line. So I need a new line here. Let's try to be as accurate as possible. Oops, I missed. So there's my new line. And now I want to see what I found out. Okay, so I don't know what I find out. Let's see. If I measure this bottom length, I get a length of, 14 centimeters. Okay. Now if I measure this length, let's see. Ah, holy smokes, it worked. 7 centimeters. Do you notice any relationship between 14 and 17? Yes, that's right. That's right. When you connect the two midpoints, that line segment is half the length of the bottom one. That's really cool. So that means BC is twice the length of DE. That's really neat. Cool. Okay, so now we've got a few more steps. Now I want to fold the diagram through this point, and I want to see where the vertex lands. So I'm just going to rip that off the table, off the thing here. Let's bend it beautifully. Well, maybe I should have pre-bent this. And let's see. So good thing I've got a nice see-through marker. Look at that. See, I'm going right through the line. Good. And where does A end up? Hey, look! PC. It's landing right on that bottom line. Oh, so that means that this height and this height are the same. Oh, neat. There's another conclusion I've got. Okay, let's put this guy back up here. And let's just give that a nice little label. So that means that this height here, let's give it 3 lines, is the same as this height here. Cool, eh? So conclusions to the line is half the height from A. It's half the height from A of the, this is a terrible sentence, I'm sorry, original height. So that midpoint line there is splitting my height in 2. Okay? So not only is this line half the length of this line, but this line and this line are each half the length of the whole. Oh, that's so neat. I got one more. You ready? Handy dandy protractor. Okay? I pop it on. And if I notice, this is 70 degrees. This is 70 degrees. So they're both the same angle. This one and this one are both the same angle. So I pre-measured these. 65 degrees, 65 degrees. So if that's the same angle and that's the same angle, what else can I conclude? They're parallel lines. What? No way! So this line here, oh, this is such a messy diagram, is now parallel to that line. So that's really cool. So conclusion number 3, I'm just going to stick to line segments here. DE is parallel to BC, which means those angles are the same and those angles are the same. Always, always. Like I just drew a random triangle and these are the results I get. And those are the exact answers I was looking for and it worked. You should try this. Okay, so now we're going to do another little investigation here. And this time we're going to investigate, and again, it's just another random triangle. Let's just call that ABC, okay? And this time what I'm going to do is I want to connect this vertex to the midpoint down here. So I'm going to split this up into 2 equal pieces. So I need to find my midpoint, and then I'm going to connect it with this vertex. So that's going to be called a median. So that's a line segment connecting a vertex to the midpoint of the opposite side. Okay, so we got to measure that out. So let's see here. Let's see, that's what, 29. So what's half of 29? 14.5. It's right there if I did it right. Yeah. So there's my midpoint. ABC, I don't know, we'll call that D. Maybe M, whatever. Okay. So then that means that when I connect these guys, I've just created what's called a median. So it connects the vertex to this midpoint. And then the question is, well, does it have any cool properties? Oh, of course it does. Why would we do this if it didn't have cool properties? This is a triangle. Triangles are full of such cool properties. So let's draw another line on here. So what I'm going to draw now is the line that's perpendicular to my base. Okay, so if I get this right, that looks a bit perpendicular here. Oops, it slid. So there's my perpendicular line. And the whole point of perpendicular lines, you guys would have learned this eons ago. How do you find the area of a triangle? Right? So area of a triangle, remember, is half times your base times your height. Okay, so this line here gives me my height. There's my base. So how, like, really, what are we trying to do here? Well, if I think of this median as splitting my big triangle into 2 halves, so I've now got 1/2 is here. Okay, we'll just color it in so you can see a bit more of a difference. So there's 1/2, there's my other half. Well, let's look. So the length of BD is the same as DC. So we'll just call those guys, I don't know, X. And here's my height. So let's just call that H, because that's creative. So let's look at all these areas and see what happens. All right. So the area of the big triangle, ABC. So that's half times, who's my base? 2x. Times, what's my height? H. Okay. So the area of little triangle ABD, half times, what's my base? X. What's my height? Oh, it's H. Okay. How about the area of my yellow triangle, ADC? Half times, what's my base? X. What's my height? Oh, it's still the line that's over here. So what did we just notice? That median split my triangle into 2 equal halves. That's the same value as this. And look at that. They're both exactly half of the big one, because the big one is twice the little ones. What a cool observation. So our conclusion here is that a median divides a triangle, so the triangle's area, into two equal halves, into 2 equal halves. So as long as I know the area of the big triangle, I now know the area of my 2 smaller ones, and vice versa. Cool, eh?